Assalamualaikum warahmatullahi wabarakatuh. My name is Khairul amsyar. Today I'm going to tell you about a type of polygon. The word polygon derived from the Greek means much or many. In geometry, a polygon is traditionally a plane figure that is bounded by a unit change. Straight line of segment closing in a loop to form a closed chain or circle. These segments are called edge or side, and this point where two edges meet are polygon. The interior of the polygon is sometimes called its body. An anagon is a polygon with n sides. The first word of polygon, before the word of gon, is represented as how many sides of this polygon. Polygon is a two-dimensional example of the general polytope in any number of dimensions. Some polygon of different kinds. They have, as long as they are closed circuit or closed circuit, we consider it as a polygon. Classification of polygon. The first polygon is hexagon. In geometry, hexagon or monogon is a polygon with one edge or one vertex. Okay. The second is diagon. In geometry, diagon has two gon or two gon is a polygon with two side edge or two vertical. Okay, third is a triangle. Triangle is polygon with three edge and three verticals. It's one of the basic shapes in geometry. A triangle with vertical A, B, and C is denoted. Okay, you can see ancient building is use triangle as a basic of its design. The number four is quadrilateral. The origin of the word quadrilateral is from the Latin word is mean quadri means four and latus means side, means four side. You can see as long as they have five side like this, that we consider it as a polygon. Not this. This is just a picture. Okay. Then is a pentagon. Pentagon is a five-sided polygon. Okay. Sum of internal angle a simple pentagon is 540 degree. Okay. One side have a 108 degree, and sum of all these side we can have a 540 degree. This is an example of pentagon in real life. Next is hexagon. In geometry, hexagon is six edge or six vertices. Total internal of hexagon is 720 degree. Some and one angle, one side have a 120 degree. Sum of all of these have a 720 degree. In real life, B is the honeycomb have a hexagon shape. Next, a heptagon. In geometry, heptagon is polygon with seven sides or seven angles. Okay, one of this each side have a 120x 4/7 degree. Sum of all these sides times 7, we can have the sum of a internal angle. The left, the building have a heptagon shape, but I think it's just a concept. I don't know is it true or not. Is it uh, real or not? Next is octagon. A regular octagon closed figure with sides similar and internal of the same size. It have a egg side, and each side have a 135 degree. Sum of all of octagon we can is 1080 degree. In the left, the MMA ring use a heptagon shape. Then they will fight inside of this ring. Nonagon is nine, nine, nine side, and each one side have a 140 degree. Sum of all all of the all of the side, sum of the internal angle, we can calculate by 140 times 9. Okay, it's the bottom of a cup. They use a nonagon shape. Next, a decagon. Decagon have a 10 side of 10 angle. Uh, the one angle, internal angle, one side 144 degree. Okay, the sum of internal you can calculate by times 10, mean 1044, 140 1440 degree. Okay, this is a real life situation. They use coin as a decagon shape. Next, hendecagon. Hendecagon is also known as a undecagon. Have a 11 side of polygon. Okay, you can see this internal one side 147, 3 over 11. Okay, it's a real life situation. Next is the decagon. In geometry, the decagon is polygon have a 12 side. You can see each side have a 150 degree. Okay. Next is tridecagon. Tridecagon have a 30 sides angle, and each side of the one side have a 152.308 degree. Okay. Actually, we have many type of polygon, but I show you it at a 13 polygon only, because we have done much time, and I hope you learn something from my slide.
Bismillahirrahmanirrahim. My name is Luqman Hakim bin Mohamed Aroff, and my ID is 5321114399. And today I will be explaining about triangles, in which my topic includes the types of triangle and the formulas concerning triangle. First up is the equilateral triangle. An equilateral triangle is a triangle in which the measures of all three sides are equal, meaning that this, and this are of the same length. An equilateral triangle is also a regular polygon in which all the angles are of 60 degrees. Here, and here, they are of the same angle, which is 60 degrees. This here is the isosceles triangle. Isosceles triangle is a triangle in which two sides are of equal length, which is here and here, while the other one is of a different length than the two sides. An isosceles triangle also has two angles of the same measure, namely the angles opposite to the two sides of the same length, which is here and here. This here is the scaly triangle. It is a triangle in which none of the sides are of the same length, same measure. Furthermore, all the angles are of a different degree, which is here, here. They are made up of different angles. This here is the acute triangle. It is a triangle in which all three of the sides are of acute angles. Acute angle is an angle of less than 90 degrees. This here is the obtuse triangle. An obtuse triangle is a triangle in which it is made up of an obtuse angle, which is over here. Obtuse angle is more than 90 degrees but less than 180 degrees. Okay, this here is the equiangular triangle. It is a triangle in which the measures of all the angles are the same, which is here, and here. They are the same angles. This here is the right angle triangle. It is a triangle in which it is made up of 190 degree angle, and this is the symbol for 90 degrees. And now we move on to formulas. The formula for area of triangle is commonly known as half times base times height. This here is the base and this here is the height. put this all together and you get the area of this triangle. Moving on, here this is the sine law. Sine law is quite simple, in which it is made up of A, which is over here, over sine A, equals to B over sine B, equals to C over sine C. Moving on, this here is the cosine law. There are three variants of the cosine law, which is, if you want to find A, then you can use the first variant, which is A squared equals to B squared plus C squared minus 2BC cos angle A. And if you want to find the length of B, you can use the second variant, which is B squared equals to A squared plus C squared minus 2AC cos B. And if you want to find the length of C over here, then you can use the length for the third variant, which is C squared equals to A squared plus B squared minus 2AB cos the angle of C. And this here is the simple question, just a simple question to strengthen the understanding towards triangle. This particular picture is not very clear, so I wrote a description concerning this triangle over here. Suppose that in triangle ABC, A equals to 71 degrees, which is here, C equals to 40 degrees, which is over here, and the length of A is of 19 cm, which is over here. Find C to the nearest tenth of a cm. Well, this particular question is quite simple, in which you just need to use the sine law. Just put in everything that you know from this triangle here into this sine law over here. Put in A, which is 19 cm over here, over sine the angle of A, 71 degrees. C is what we need to find, over sine the angle of C. And you rearrange them together. Put C as the subject, and you get this particular thing, which is 19 sine 40 degrees over sine 71 degrees, and you get 12.9 cm. Well, that's it from me.
Okay, Assalamualaikum. My name is Mohamed Faris bin Ibrahim from class 1BME2. I will be trying to explain about Pythagoras theorem. Okay, about this Pythagoras theorem is basically a theory made by this guy named Pythagoras. So who is this guy? He was a Greek philosopher, mathematician and scientist. So one of his contribution in maths is Pythagoras theorem, and he is also the one who proposed that everything that happens in this world can be quantified and mathematicized. It means that everything that happens in this world, such as he proposed that something like Earth circling around the sun, and on how music is played. Everything that regarding science can be calculated. So this is the guy who proposed that everything that cannot be calculated before can be calculated. Okay, I proceed. So Pythagoras theorem states that in a right angle triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. Okay, let me explain this. Let's say for this picture, the dark blue is the right angle triangle. So Pythagoras states that the area of the square connected to the hypotenuse, see here, this area of the square here is equals to the area of the square connected to both A and B. Okay, so there is equation here: A squared plus B squared is equal to C squared. So So a squared, a times a plus b times b equals to c times c. Okay, this can be proved by this picture. Let me explain. So for this example, this right angle triangle, the hypotenuse is 5. Okay, so the area of the square connected to the hypotenuse is 25. Say it's 5 times 5, 25. So the area of the other two sides, area of the square connected to the other two sides. So this one is 4. 4 times 4 is equal to 16, and this one is 9. 3 times 3. So Pythagoras states that square connected connected to this side and this side is equals to the square connected to this side. So 16 plus 9 is equals to 25. So it is proved. Okay. Before that, this can be further improved. Now let me show you this video. So in this video, okay, here it shows that there is a square. There's a square in a square. Square here in a square. Okay, the big white square. Okay, so in the picture here we can see that there are 4 identical right angle triangle. Here 1, 2, 3, 4. Okay, the area of this is c squared. If you notice, the square is connected to all 4 hypotenuse of all 4 right angle triangle. This hypotenuse for this triangle, this hypotenuse for this triangle, hypotenuse for this triangle, hypotenuse for this triangle. Okay, so we can see that the area of the c square is black in color. So let me click this. The area of c squared, the black color, is equals to the area of the a squared, a which is the one side of the triangle, and the other one is b, the other one side of the triangle. Okay, so this video wants to show you the area of the a squared plus b squared is equals to the area of the c squared. Okay, so it is proven then. So application of the Pythagoras theorem. So for example, for this equation, find b. So the question already state that it is a right angle triangle. So we can straight away use the Pythagoras theorem. So a squared plus b squared equals to c squared. So we just plug in the value 9 for a. Since 15 is the hypotenuse, so we put it as c. So we plug in the value, we calculate, and then we get the b. Okay, so Pythagoras theorem is also capable of telling whether a triangle has a right angle or not. So we use straight away the theorem. Okay, such as for this example 26, 24, and 10. So if you want to know which side is the Pythagoras, we just need to find the highest value. Okay, since the highest value of these three numbers is 26, so we assume that 26 is the hypotenuse. So we put the 26 in C. Okay, and the other two is A and B. So we plug in the value. So a squared plus b squared equals to 10 squared plus 24 squared, 10 squared, 24 squared equals to 676. So then we calculate the hypotenuse value. 26 squared plus equal to 676. So we can see that the left hand side is equal to the right hand side. So if it is equal, so it's proven that this triangle is a right angle triangle. Okay, so I think that is all from me. Thanks for watching.
Assalamualaikum warahmatullahi wabarakatuh. My name is Jamalulai bin Ariffin, and I'm from 1BME2.
So today I would like to explain about another three things of quadrilateral, which is trapezoid, isosceles trapezoid, and also a square. These things we have learned in our secondary school and also even our primary school. So we will start with trapezoid first. A trapezoid is a four-sided flat shape with straight side that has a pair of opposite sides parallel. So I want to show you that this is a normal trapezoid and this is isosceles trapezoid. The parallel sides are called bases. This is basis A and this is basis B, and the other two at to another side is called leg, and the distance at the right angle from one basis to another is called altitude. So for the perimeter of trapezoid, you just simply add A basis B, the leg C, and the leg D will get the perimeter. This is the formula for area of trapezoid. Uh, the formula is to just add the basis A and the basis B, the value I mean, and divided by 2, and you just time with H. Here is the example from the question. Find the area of trapezoid with bases of 10 inch and 14 inch and a height of 5 inch. We need to find the area. So we know the formula for area of trapezoid is half times P1 plus P2 times H. So we know the value, and we just simply put it in the formula and we will get the answer of the area. Now the example 2, the area of trapezoid is 52 square inch and the bases are 11 inch and 15 inch respectively. Find the height. Now we need to find the height. The area will be given and the bases also will be given, and we just do the same thing. We just add the value to the formula and we will get the. Now the median of trapezoid. The median is a line segment halfway between two bases. Yeah, show from the picture. The median length is the average of the two bases length. M equal to A plus B divided by 2. So we can calculate the area if we know the median of the trapezoid. The formula is M times H. Now we're moving on isosceles trapezoid. First, isosceles trapezoid is same as normal trapezoid, but it is just the basis A and the basis B is equal, and it stated in the slide an isosceles trapezoid called an isosceles trapezoid by the British, also British, Bronstein and Semenyev in 1997, page 174, is trapezoid in which the basis angle are equal and therefore the left and the right side are also equal. That's it. So now we have square. Square is probably the best known of the quadrilaterals. It is defined as having all sides equal and its interior side all right angle, which is 90 degrees. From this, it follows that the opposite sides are also parallel. A square is simply a specific case of a regular polygon. In this case, with four sides, all the facts and properties described for a regular polygon apply to a square. You know, I don't put a picture of square because square is perfectly equal side. It has 90 degrees, and now this is abbreviation you need to know. The vertex is a corner of the square. Every square has 4 vertices. The perimeter, area, and diagonal. The area for square is just S squared. S means the length of one side of a square. So this is the from the first slide of a square. It stated that a square can be thought of
as a special case of other quadrilaterals, for example, a rectangle, a parallelogram, and a rhombus. So this is area of the square as I said just now, okay, as square. And this is diagonal method to find area. If you know the length of a diagonal, the area is given by area equal to b squared over 2, where this d is the length of either diagonal. The length of diagonal can be found by using the method described in distance between 2 points to find the distance. So it's just the same thing method. And thank you. I'm sorry for my broken English. If you don't understand, you can study furthermore with using Google or ask your teacher. Thank you.
Hi guys, my name is Darence and polygons. I will do quadrilaterals to be exact. What is a quadrilateral? Quadrilateral is a polygon with 4 sides, 4 edges, and 4 vertices or corners. Sometimes the term quadrilateral is used by analogy with round. The origin of the word quadrilateral is the two Latin words quadri, a meaning of 4, and laterals meaning side. Quadrilaterals are simple, not self-intersecting, or complex, self-intersecting. Simple quadrilaterals are either convex or concave. The interior angles of simple and planar quadrilaterals ABCD adds up to 360 degrees of arc. That is, angle of A plus angle of B plus angle of C plus angle of D equals to 360 degrees. A parallelogram is a quadrilateral with two pairs of parallel sides. Equivalent conditions are that opposite sides are of equal length, that opposite length angles are equal, or that the diagonals bisect each other. Rhombus or rhomb, all 4 sides are of equal length. An equivalent condition is that the diagonals perpendicularly bisect each other. An informal description is the pushed over square. Rectangle has all 4 angles that are right angles. An equivalent condition is that the diagonals bisect each other and are equal in length. The area of a quadrilateral can be expressed in trigonometric terms as A equals to 1 over 2 PQ dot sin theta, where the lengths of the diagonals are P and Q and the angle between them is theta. In the case of an orthodiagonal quadrilateral, example rhombus, square and kite, this formula is reduced to A equals to 1 over 2 PQ since theta is 90 degrees. A parallelogram is a rectangle that has been pushed over. Opposite sides are the same length and they are fixed. What have a parallelogram and a rhombus got in common? The answer is opposite sides are parallel and no angle are right angle. Example, construct a parallelogram ABCD with sides AB equals to 4 cm, AD equals to 5 cm and angle A equals to 60 degrees. Solution step 1. Construct the line segment of AB equals to 4 cm. Construct the angle 60 degrees angle at point A as shown in the diagram. Step 2. Construct a line segment AD equals to 5 cm on the other arm of the angle. Then place the sharp point of the compasses at B and make an arc 5 cm above B. Step 3. Stretch your compasses to 4 cm. Place the sharp end at D and draw an arc to intersect the arc drawn in step 2. Label the intersecting point C. Join C to D, B to C and form parallelogram ABCD. To find the area of a parallelogram, the base and the height of the parallelogram must be perpendicular. The formula is base times height. Example, find the area of a parallelogram, base of 12 cm and a height of 5 cm. If you times the height by the base, you get 60 cm square. Rhombus has got 4 sides of equal length and opposite sides are parallel to the angles are equal. What is the difference between a square and a rhombus? The answer is a rhombus has got no right angle. Step 1. Draw a straight line AB. Step 2. Stretch your compasses until it's more than half the length of AB. Put a sharp end at A and mark an arc above and another arc below line segment AB. Step 3. Without changing the width of the compasses, put the sharp end at B and mark arcs above and below the line segment AB that will intersect with the arcs drawn in step 1. Join the 2 points where the arcs intersect with a straight line. This is the perpendicular bisector of AB. P is the midpoint of AB. Connect all the points between A, Q, B, R and you will result the rhombus as shown in the diagram. For rhombus, there are many ways to find its area. Consider the area of the following rhombus. Method 1 is to find the area of triangle PQR and plus it with the area of triangle PRS. Method 2 to find the area, simply multiply the base and the height of the rhombus. Method 3, since all the sides of the rhombus are the same, take one side and square it. Then multiply it with the sine of any angle inside the rhombus and you get the area. The rectangle is oblong and contains 4 right angles of 90 degrees. It has got 2 pairs of equal sides. In a rectangle, what is the same as a square and what is different? The answer is the rectangle has got 4 right angles each 90 degrees. This is the same as a square. However, a rectangle does not have 4 sides of equal length. To draw a rectangle, there is no need for step-by-step guide as we see it most in our daily life. Any object that has got 90 degree angle for all its 4 sides and each 2 of its sides are same in length is considered to be a rectangle. The formula to calculate the area of rectangle is height times base. Application of polygons in daily life. Parallelogram can be used as structures for buildings or as a sculpture. Rhombus is usually used as a signage for traffic rules, or it can be used as a mechanical crank as shown in the picture. Rectangle has many applications, but one of the few applications are a window grill and a swimming pool outline. That's all. Thank you for watching.